One more problem for equilibrium calculation, and I think we need a little practice on this, and that's why this is the fourth problem and not the third one. So this is the fourth problem that we're working on for equilibrium calculations. Okay, so here is the problem. The equilibrium constant for the decomposition of phosgene, which is COCl2, is 4.43 times 10 to the negative 3 at 427 degrees Celsius. Calculate the partial pressures of each component of if the pressure of phosgene is 0.760. Okay, for this one. So here we have a couple things. Okay, and so that's why I kind of chose this problem to work on. First of all, the pressure is given to you, not the concentration. All right. So the temperature here becomes important. In the previous problems, the temperature was not important for us because Kc does not require temperature. But as soon as you deal with pressure, then you have to work with pressure and temperature both. Okay. And so let's go ahead and start. Okay. First of all, and our temperature is 527 plus 273, which is 800 Kelvin. I kind of like to do all the mundane stuff first so that you don't have to worry about it. Delta N is equal to 2 minus 1, one coefficient here, and 1 here. So 2 minus 1, and that is equal to 1. So what we're going to do is we'll calculate Kp for this one. We don't need to work on Kc. We can do Kp for this because we're required to ask for pressure calculations. So then Kp is equal to Kc RT delta N, which we have done the calculation before, and this is equal to 4.43, and then R is 0.0821, and the temperature is 800. All of this is raised to the power of 1, which really it's not that much, so then 0 or nothing really. 0.304 is Kp. Okay, so we will need that later for our calculation. So let's go ahead and write the equation again. COCl2, everything is in gas form, so I'm going to save myself some time here. Cl2, my initial, now instead of writing concentration, we're going to work on pressure. Okay, so the initial pressure of phosgene is 0.760 atmosphere, and there is no product form. When the change happens, then you lose some of your phosgene and you form carbon monoxide, and you also form chlorine. At equilibrium, the pressure will be 0.760 minus X for phosgene, X for carbon monoxide, and X for chlorine. Okay, so then our Kp is going to be set up just like we did before with products over reactants, which means X times X divided by 0.760 minus X. Okay, so that is our Kp, which is equal to 0.304, and let me go ahead and put semicolon over here. So 0.0304 is equal to X squared over 0.760 minus X. Again, you cannot take this equation and square root everything. Okay, so which means we're going to have to use the quadratic equation, all right, over here. So again, go ahead and open up the brackets, which means that 0.304 times 0.760 minus X is equal to X squared. All right, and so then X squared plus 0.304X minus 0.231 is equal to 0. Yes, I've already worked this problem, so I kind of know the numbers, but otherwise you should work it out and see how you get all these numbers, all right? Okay, so then here is our A, here is the B, and here is our C value. And again, the quadratic expression is X is equal to minus B plus minus, and then square root of B squared minus 4AC divided by 2a. Again, I always urge you to write your equations. I always write them for you, and I would really like it if you also write them for me. 0.304 plus minus plug in all the numbers here. So b squared is 0.304 squared minus 4, and a is 1, and c is minus 0.231. Again, don't forget the minus. All divided by 2, and a is 1. Calculate everything, and hopefully you will come up with x is equal to 0.352 atmosphere. If your answer is different, please let me know. I think it should be this. No, it is this. All right, and then carbon monoxide and chlorine pressure, okay, of these two is going to be 0.352 atmosphere, and then the pressure of COCl2 of phosgene will be 0.760 minus 0.352 atmosphere, which is 0.408 atmosphere. So what was the question again? Gosh, so much math that we forget. What are we calculating? We are calculating the partial pressure of each component. Okay, so then this is our answer right here. And so is this. Okay, so that's how you solve this problem. Again, with the quadratic equation, they're just a little involved, but otherwise it should be fine. And I think the new calculators probably have this equation already in them, so you don't even have to do much. Probably just plug in the ABC. Check your calculator.